was going to talk about gluonic fields at strong coupling.
Okay, thank you to the organizer for giving me this nice opportunity to give my talk. My background is not in string phenomenology, but it's nice to share with you. Well, I will talk about on the beaming of gluonic fields and strong coupling. This work was in contribution, my collaborator Alberto Vijosa and Cesar Aragon from the Nuclear Institute of Mexico, and this talk is based in this paper. First, I will talk about the motivation very quickly. I don't want that you be late in the dinner, and then then the outline, the origin of the beaming, then pulverizing the string, and the conclusion very quickly. So, after the discovery of the ADS-CFT correspondence, we have at hand a very powerful tool to explore certain non-abelian strongly coupled gauge theory. Particularly, one of the natural aspects to explore in those theory is the way in which disturbance in gluonic field propagate when a quark undergo in arbitrary motion. We can add heavy quarks to this setup by introducing open string on the gravity side. More precisely, the endpoint of the string corresponds to the quark, and the body of the string is will give us the gluonic profile. So, what we expect about the radiation at strong coupling is that at strong coupling, the gauge fields are expected to re-radiate, different to the classical electromagnetism. That's why, because at a strong coupling, radiation promptly isotropizes. However, in Atanasio, Chesler, Liu, and other people in this paper found that heavy quarks undergoing uniform circular motion at relativistic speed, this in only a relativistic speed, in the vacuum of the conformal field theory that is dual to pure ADS geometry, give rise to a gluonic field profile that essentially coincides with the familiar synchrotron spiral of classical electromagnetism. They argue that maybe the ADS-CFT didn't understand very well this radiation at strong coupling, but soon after the Atanasio war, Veronica Juveni, in this paper, proposed an interesting explanation for the beaming in strong coupling gauge theory, which was shown to be successful only in the uniform circular motion. So Veronica Juveni's proposal was, it was shown that at least for the particular case of uniform circular motion, that the string bits give rise to localized contribution to the boundary of ADS. This because they move ultra-relativistic, a large C, and therefore generalize both fields that are themselves beamed. That was he argued. So each string bits should generate a gravitational shock wave. Therefore, the back reaction of the full string should be well approximated by a linear superposition of shock waves perpendicular to the string velocity transverse. Okay, that's what Veronica found. He reproduced the same pattern of the radiation of electromagnetism and weak coupling. In ADS-5, the shock wave planes turn out to be hemisphere whose equator lies on the boundary at C equals 0. You see the shock wave is in a null plane that is perpendicular to the transverse velocity here of a bit of the string. So my outline and main results of my work, we use them very well known example of the ADS-CFT correspondence. That is a super Young-Mills with n equal 4 superchargers in 4 dimensions. That is dual to a type 2B superstring theory in ADS-5 across a compact space in 10 dimensions. here the marvel of this duality is that in the Young-Mill theory we have a Gerhardt coupling and a number of color large, but in the other side of the theory we have the coupling of the string and this term here, that is the strand length divided by the radius of the curvature is very small. But more general, here we have complicated computation, and here we have easy computation in the side of the wiki coupling or on the gravity side. So the aim of this work was to employ the ADS-CFT correspondence to establish how general the phenomenon of beaming is in a strongly coupled gauge theory, because Veronica did all the work in heuristic case, and in particular to identify the condition under which the shock wave of Huveni's prescription is valid. That's very fine because it's very difficult if you have a background for example, if the very well known ADS-CFT theory, if you have the quarter moving in a vacuum that is dual to a pure ADS, the calculations are very easy because we have a temperature equal 0. But when we have temperature finite, we have background very difficult to compute because it's very difficult to solve the question of motion. But with this prescription of Veronica, it could be very nice. So inclusion of quarter in the theory is very simple. You only in the gravity side you only put a classical string. That this string is the source of perturbation of the metrica, and they will give us of the dilaton and the graviton. So the Gluonic field sourced by the quark can be mapped of computing the expectation value of the local maximal supersymmetric Young-Mill operator. This one, that I will have an explicit connection that was made by the Klebanov, Gupser, and Polyakov. Is very nice because here we have the super Young-Mill theory that is dual to only solve the linearized equation, the Einstein equation, but close to the boundary of ADS in the case of the trace of F square. So we have then the Nambu-Goto action here, and we have the good thing is that now we have the solution the Nambu-Goto action by Mihailov. So we have this now, and from Mihailov's solution we have this. So we can say that given an event at a retarded time in which the quark is sufficiently relativistic, the null line on the string worksheet remains near to the boundary of ADS, even far from the source. That implies that the field generated by this point of the string will be beamed when they react to the boundary. Therefore, the fields on the gauge theory side will correspond localized. So, as you can see here, this color line are the Mihailov lines. So the Veronica proposal revised. Basically, Veronica said that the reaction of the full string is well approximated by a linear superposition of gravitational shock waves normal to the string transverse velocity. So it's crucial for our calculation how the transverse velocity. We compute them in the Poincaré wedge. It's very easy. And we also noticed that the integrand of the Nambu-Goto Lagrange could be writing in terms of the transverse velocity. So it's very important for us have the dilaton and the graviton. We know how to compute them. It's just for green function. And we also know the source, that is the Nambu-Goto action. So we then would like to pulverize the string to match the Huveni proposal, but in the case of the dilatonic, that is very easy because it's an scalar. So we have the dilaton field in terms of the transverse velocity. here our interest is to determine under what condition this dilaton field can be approximated by using point particles in place of the string, as Gluonic proposed. So we have the dilaton field, but only for a particle. And what we really found was that for the purpose of computing the dilatonic field, and consequently the trace of f squared, the string or segment of it can be approximated as a collection of particles moving when velocity, this is the velocity of the particle, equal to the velocity, transverse velocity of the bit of the string, only to the extent that, in this case, when the transverse velocity of the bit string is approximately to the velocity of the particle, and this term is constant. So only in this case. So we found that the required condition for validity of the Veronica-Gluonic proposal are these three conditions. So we found we found these three conditions, and this must be true for all the string embedding. So the conclusion are the ADS-CFT duality teach a new feature of the radiation pattern in some non-abelian strongly coupled conformal field theories, the presence of the beaming. So surprisingly, that effect is complete analogy with the with coupling expectation. We provide a simple and intuitive explanation to the beaming in such a theory using just the shape of the string structure of the Mihalov solution. And we show that the interesting Veronica-Gluonic proposal seems to be valid only for the uniform circular motion. Also, we prove with the, now that we get the condition for the validity of Veronica-Gluonic, we prove with many gauge, like Mihalov gauge, reversal Mihalov gauge, and some trajectory, and we found that these conditions only are true in the case of on the circular motion. Unfortunately, it's not for much general trajectory. Thank you.
Thank you very much. Questions?
So you said that you put a string and then you study how the metric and the dilaton, how they behave.
Yeah.
And what about the B field, or there's no B field? Like is the other field that the string produces?
No, because in the dictionary that we are just, you see, we are not interested in all the field because we know the dual of the, for example here, we have two fields, the dilatonic field and the graviton. So we only are interested in this guy, in the expectation value of the local maximum supersymmetrical Young-Mills operator, that is this. And we know that the dual to this operator is the dilaton. So we don't care about the other.
Set to zero.
Sorry?
It's set to zero. Zero. It's put it to zero.
No, it's not zero. It's not zero. The fact is that we don't care about it.
So you use the Namu-Goto action that
Yeah.
do you think there's anything different if you put if you use DBI action, for example?
Which one?
DBI for the string.
No, because here, if you put, for example, the quad is dual a classical string, so we only need to use the Namu-Goto action.
Yeah, well, I guess you could also use DBI action.
Yeah, it could be.
Yeah, in case there's anything else you could see, but maybe since you see what you want.
Yeah, it could be good proof with this action. Yeah.